Okay, so today we're going to do exercise 1.3, integrals in the form of x to the n. This is the form that we're going to use. Now let me explain this formula in context. So we're going to start off with question 1. And we're asked to integrate x to the 3. Now, what we're asked to do here is, see m plus 1, m equals 3. Okay, and what it says to do is, to integrate this, what we're going to do is we're going to put x, and then we're going to add 1 onto n. So n plus 1 therefore equals 4. So it's going to be x4, and we're going to divide it by n plus 1. n plus 1 is basically, once again, 4, and plus c. Okay, now what the c stands for is a number, because what integration is what is the original function. Okay, so this is the original function, and if we differentiate this function, what we're going to get is 4 goes back to the front, 4 multiplied by a quarter cancels, take 1 away from the power, and you get x3, the constant disappears. So basically integration is the reverse of differentiation. Okay, and the c value can be any number, because any number, whether it's 100 or minus 10,000, it differentiates it into 0 and disappears. Okay, so to answer the first one is f of x equals x power 4 over 4 plus c. Okay, let's try another one, for instance, like number 3. Okay, so we're going to do 1 and 3 so far. So what this is x to the power 4, x power, this one here is going to be 5x to the power 4. So the integral of 5x to the power 4. So what we're going to do in the case of this is we're going to ignore the 5 and put the 5 straight into the answer. And what we're going to do is just primarily concentrate on integrating the x4. So n, once again, n is going to equal 4, n plus 1 equals 5. And what it says to do is x to the power of 5, which is this one here, and then divided by n plus 1, which is all over 5, plus c. The 5's will cancel, and our answer will be x5 plus c, because when you differentiate x to the power 5, you're going to get 5x to the power 4. Okay, let's try another one like minus x. So number 4. Okay, so this time we're going to have minus 1 times x. Now x is going to be x to the power 1. Okay, when we integrate this, we're going to have n equals 1. n equals 1, n plus 1 equals 2. So therefore it's going to be minus 1. Once again, bring the number straight across. Now integrate the x to the power 1. When you integrate the x to the power 1, what we're going to get is x to the power of n plus 1, which is 2, divided by 2, plus c. So it's going to be minus a half x squared plus c. So when you differentiate that, you'll get minus 1 back. Okay. So let's go a bit harder, like question 7. Okay, so in question 7, what we're going to have is the integral of minus 2. So the integral of minus 2. Okay, now what we can say about minus 2 is we can do it 2 ways. Okay, the first way is to realize that anything that differentiates into a number has to have an x beside it, so you'll always just add on an x. So we got minus 2x plus c is one way of thinking about it. Likewise for number 6, what you can say is the integral of 5 dx is just going to be 5x plus c, because when you differentiate 5x you get 5, when you differentiate minus 2x you get minus 2. That's just the way to do those ones. Okay, now the next ones are going to be slightly trickier. So for example number 9. Okay, so number 9 is going to be the square root of x. Now square root of x is x to the power of a half dx. And once again the integration rules applies. If n is a half, n plus 1 is 3 over 2, 3 halves. Okay, so it's going to be x to the power of 3 over 2, and then it's going to be 3 over 2 on the bottom, plus c. Remember what happens with fractions? You bring the fraction up and turn it upside down, so we're going to get 2 over 3, x to the power of 3 over 2, plus c. Usually the power well, if it's in fraction form, we'll usually the power fraction will be multiplied by the same fraction upside down. Okay. Now what about number 10? In the case of number 10, what we have here is we're going to rewrite it as 2 over x squared, x power half, sorry. Then we're going to write that as the integral of 2x to the minus a half. Now when we integrate this, okay, we're going to have a 2 at the front, and we're just going to worry about integrating the minus a half. So what happens is we're going to let n equals minus a half. N plus 1 therefore is going to equal plus a half. So we're going to have is x to the power of n plus 1, which is going to be a half. And then all over n plus 1, which is divided by a half. Now plus c. Turn that half upside down. And when you turn a half upside down and bring it to the top, it's going to turn into 2. 2 multiplied by 2 is 4. It's going to be 4x to the power of half plus c. Okay? And that's our answer there for basically 1 to 10. Okay, so we can see in the next section is that there's 2 different integrals. Okay, so integral of 3x squared, integral of 8x. Now to do these questions, you can treat the integrals as 2 separate questions. Okay, so for the first one, what we're going to do is, once again, n equals 2, n plus 1 equals 3, so it's going to be 3, bring the 3 straight down, now integrate the x squared part, it's going to be x to the power 3 over 3. The 3 cancels and we get x cubed. Likewise for this one here, we're going to have n equals 1, n plus 1 equals 2. So what we're going to get is 8, go straight down, we're going to get to the power of n plus 1, which is 2, divided by n plus 1, which is divided by 2 again. So we're going to get x cubed plus 4x squared plus c. Okay, for this part here. Okay, so that is question 11 done. Okay, so now we're going to move on to question 13. Now, in question 13, what we have here is 2x squared. Question 13 is integral of 2x squared minus the integral of 5x. So you can divide up the integrals into 2 parts. And once again, we're going to start off with bringing down the 2 because it's a constant. Okay, so the 2's doesn't matter. So we can say 2 times the integral of x squared. So for this one, n equals 2, n plus 1 equals 3. So it's going to be 2 times x3 all over 3. The next one is going to be the integral of 5x, so it's going to be 5 times, now in this question it's x to the power 1, so n equals 1, n plus 1 equals 2, so it's going to be 5 over x2 all over 2 plus c. Okay, and that's our answer for this one here. Okay, so moving on towards question 15. Okay, so 13, now we're going to do 15. So in question 15 we have the integral of 4x squared, 4x cubed minus 2x cubed. So from now on you don't really have to write them out longhand anymore, so what we're just going to do is the integral of 4x cubed minus 2 over x cubed dx. So just integrate both of them separately, okay? So we integrate them both separately. The first one is going to be n equals 3. n plus 1 equals 4. So we're going to get is 4 times x to the 4 all over 4. The 4's will cancel. The next one, the 2x cubed, well, I suppose what I should do with the 2x cubed there is change it to 2x to the power minus 3 using the integral of indices. N this time equals minus 3, therefore n plus 1 equals minus 2. So we're going to get 2x to the power minus 2. All divided by n plus 1, which is minus 2. Now we can see here that we have a minus 2 divided by a minus 2, which cancels. So we're going to get x4 plus minus x plus x to the minus 2. And remember the c value at the end. Okay, so that's question 15 successfully done. Now we're going to go on to question 16. Now in question 16, what we're going to get is the square root of, the integral of x to the power of a half. That's going to be 1 over x to the power of a half, which will bring up to minus x to the power of minus a half dx. Now that we're here, we can start the integration process. N equals a half, n plus 1 therefore equals 3 over 2. So when we integrate this, we're going to get x to the power of 3 over 2. Then we're going to have all divided by 3 over 2. 3 over 2 goes to the top, turns upside down, so it's going to be 2 over 3. 2 over 3 x to the power of 3 over 2. And then finally the next one is n equals minus a half, which means that n plus 1 equals plus a half, so it's going to be minus x to the power of a half, all divided by a half. Once again, dividing by a half, you bring the half to the top, turn it upside down, so it's going to be 2x to the minus, 2x to the half. So there you go there. And then remember your plus c. Okay, now we're going to do number 18, number 19. Okay, so in question 18, what we're going to do is this. X squared bracket x plus 5 dx. Okay. So what we're going to do is going to multiply it out first. We're going to get x cubed plus 5x squared dx. And once we've done this, what we're going to do is we're going to integrate them. So when you integrate the first one, n equals 3, n plus 1 equals 4. So it's going to be x4 divided by 4. Remember, x to n plus 1 over n plus 1. And then this one here is going to be 5 times. Now in this case, n equals 2, n plus 1 equals 3. So it's going to be 5x3 over 3 plus c. Very easy question. Okay, and then we'll go towards number 19. So in question 19, what we're going to have is x to the power of a half multiplied by x plus 1 dx. We're going to multiply it out. We're going to have x to the power of 3 over 2 plus x to the power of a half dx. Now, what we're going to do is n equals 3 over 2, n plus 1 equals 5 over 2, n equals, so we're just going to do the first one first, which is going to be x to the power of 5 over 2, divided by 5 over 2, turn the 5 over 2 upside down, and we get 2 over 5 when you bring it to the top. Okay, so that is going to be that there. 2 over 5 x to the power of 5 over 2. Next one, n equals a half, n plus 1 therefore equals 3 over 2. So we're going to get plus x to the power of 3 over 2. Now remember, it's going to be 1 divided by 3 over 2, but when you bring the 3 over 2 to the top, you turn it upside down to become 2 over 3. So it's going to be 2 over 3, x power of 3 over 2. Please remember the plus c value. Okay, so that's it.